Hi Lisa, so this is the ejector venturi I was trying to describe to you that I'm working on to create the vacuum that will pull air through the biomass gasifier I'm working on. So it's basically going to work like a suction vacuum on the end of the system to pull the gas out, which at the same time pulls fresh preheated air into the system. And it's a much more robust solution than the blowers that I have used in previous versions. Anyways, first I had to make a little test rig so that I could compare the vacuum of different prototypes against each other. So before I explain how the thing works, I had to make a quick manometer so I could actually measure the vacuum. So I just took a piece of 1/4 inch internal diameter clear poly tubing, folded it into a loop. I had an old tape measure that it came from a busted, burnt tape measure that I had. Wire tied that to a piece of cardboard with a tape measure just so I could compare different prototypes against each other and see how much draw they were getting. So one end is hooked to the inside of the bottom of the pipe here, and the other end is just left to the ambient pressure. So if a lower pressure is observed, the water is going to rise on the side that has a lower pressure. It works similar to the way a barometer works for testing atmospheric pressure. So the way this works, this would be where the intake is, pulling the gas out of the gasifier. It comes up through this pipe. This is all one extended piece. Just takes a turn here. Here, I've added a quick connect to hook compressed air to it, pressurized air, and a little ball valve here, so that I can inject air through this tube, which comes up here, and in this design, which has proved to be the most effective, ends right here, probably a little less than 1/3 away into the constricted section. This is 1 inch pipe, or 1 1/4 inch pipe to 1 inch, expands back out to 1 1/4. And okay, so we're back. Girls just got home from school. All right, where was I? So the this inside tube travels up inside this pipe, ends right about there, and it's very tiny. It's less than 1/4 inch opening. So, how does this work? The relationship between velocity and pressure. As velocity increases, pressure decreases. A flow through this pipe, large to a constricted area and large again, the constricted area would always be of a lower pressure because it's a smaller volume. So it flows to stay the same. Velocity has to increase here. That's lower pressure. Now I am going to inject a small, high velocity, dense, very compressed airstream in there and exacerbate this low pressure area. That's going to create, basically the low pressure is going to create a little bit of a hole that pulls all the molecules around it to it because it's of a lower pressure. So it's going to induce all the other air in this small constriction to move at a higher velocity, even a lower pressure. It's going to expand here, lower pressure, and move all this mass of air at a high rate of velocity. So this is all a low pressure area of moving mass compared to everything preceding where I'm injecting the air. So this creates a real low pressure hole That's what creates a vacuum. Okay, so you can test this. I can test up to 16 inches with my busted tape measure of water pull. Oops, sucked it right out. So I have quite a bit, more than enough pull, vacuum for what I need, and it's a variable, and I could even inject a water stream into it if I want to. The biomass gas, especially wood gas, is about 1/3 carbon monoxide, and if I inject water into that stream, that carbon monoxide will probably pull that other oxygen off of the H2O, want to go to CO2, and then I'll produce even 2 more hydrogen. So it's already 30 some odd percent hydrogen. It would probably push it over 40%. Excellent. All right, talk to you soon, Sister Shakalaka.